Okay, so in Codechef today, usually Codechef has pretty nice problems. Just that the test cases could be a bit weak, like how in the ICPC stream, I chased a problem by randomizing it, but it Conquer of Tourists managed to find a counter test case. But I think that's still a bit rare. Usually the test cases are nearly good enough, and cheesing is hopefully not a big part of today's contest. Rated of 5 stars. I don't know if that's a good thing or a bad thing. I'm about 31 points away from 6 stars. Not sure if I'll get there today, but let's see. Okay, if they refuse to move to a height that they visited before, that means if they start a sign, they stick to that sign. So it either completely decreases or completely increases. So I can visit J if J is hi plus j minus I or hi minus j minus I. So these are the two cases, and obviously that's with the body group. So if both of us can reach the same point, so either I go right and he goes right. So if right, so I just have to see if they can meet at any point in the middle. If they can meet any point in the middle, it's not necessarily that they have to meet each other. Where's my pen? So either there's a value here and it's like this, or it's like this, or it's like this. So for every peak, any of these can meet each other, and for everything, any of these can meet each other. So now answer can be in long. It will be long. Using big is equal to long. And sure, now I find every point. So now to make my life easy, I'll have to gather the list of strictly decreasing, strictly increasing points. So let's start with first. So stud vector of, so you have an array of into lengths. Now for int I equals 0, I plus 1 is less than n, I plus plus, and less than n. So you either what's the easiest way to tackle this? One is to get all the points and up, down, up, down, up, down. So differ by exactly 1. Diff of n minus 1 comma 0 for int I is equal to 1, I less than. So that's the difference. Now I just need to find a streak of ones. So if I have a difference array, so you have 1, 1, minus 1, minus 1. So now you have a length 2, length 2. Now this means there are 3 people in this and 3 people in this. So it's 3c2 plus 3c2, and since there's a peak here, you have 2 here and 2 here, so it is plus 2 times 2, 3, 3, 6, 10. Perfect. So this method works well. So that reaches the outer bounds, and so the total length is actually this. And it doesn't matter what it is. J minus I. I is equals to minus j. And so that's done. Now what I would do is auto c2 big X return x times x minus 1 by 2 for auto is the size of length I plus plus. So ans plus is equal to c2 of length of I, and if I plus 1 less than size of length, then answer plus c equals to this one. What's the issue? Oh. Bit too slow. In space orbiting around the Earth, CI indicates maximum capacity of the ith station can hold. Additionally, there are Q missions that we carried out. Each mission has requirements a crew requirement of X and storage requirement Y. Why is it not XIYI? The crew must stay in a single cabin, and while the other N-1 cabins are used for storage. Okay, it's I like safe excellence area. Why should not exceed the sum of N-1? So the where is Q? I think they fucked up the format. It's N. Now you have 4. Oh, so you have some, there exists I dot ci less than equals to x, and t minus ci is less than I wonder what I'm smoking. Ci is greater than equal to y. Now I can increase this. So total changes that I would have to do. Now if this is greater, I would have to increase y minus t minus ci max of this comma 0 plus x minus ci comma 0 max of this comma 0. So is it optimal to choose to either maximize this, minimize this? So find the smallest ship greater than equal to x. That's where I search is equal to x. Now after that, if none, increase the largest and do it. If exists and has gap, so it can be 1, 2, 3, 8, 9, and your size is, let's say, 4. Now it's better to spend some money here and leave the rest for the group rather than do it. So I will check both. So check both. If it exists, then that's the best you can do. Why? Usually they have better questions, unless I've misunderstood something. Then using big is equal to long start vector big V and Q start. What's the range of this? Or I can do that query by query, that's still fine. So that's the accumulate part, and then for q minus big x y start c in x y, and auto gb is per bound bx auto the bonus code. So just above and just so you have both, and what you do is now if j is not equal to v dot end and star ja is, so I just need two values, big huge is so if j is v dot end, then it's not possible, I don't get -1, else I would, it's star ja, big small is, if jl is v dot, actually jl will always have a value, yeah, jl, so then I will take JL and increase it, so big cos is equals to JL minus x minus small, and I would add the cost of this, and so some minus some drawing small, and so whatever this is and how much this is smaller than y. Perfect. Else big cost 1 is equal to 0, cost 2 is equal to 0, so cost 1 is, if I take that, huge plus this, so plus, so it's just that. Now cost 2 is that I don't take that and take the smaller one, so I have to upgrade it, so cost plus equals to x minus small, and whatever I need to add here. So yeah, output stud min cost 1 cost 2, output cost, there's no ranges version. Just sad. Should I stress test? I should maybe. Fuck it. should just learn to stress this better. So both coordinates should remain positives, and I'm assuming 0 is not positive, so they just start at 1 1 and keep moving. Oh, scary. So it's either nm or nm by I square, which is what we want to hope. Actually, not necessarily, but whatever. It's never been so over. So there's no bounds on the sum or anything, so I'm guessing it's a closed form solution. They both can go to 2018. Well, one thing is, at some point you would go on. Oh. Right. $28, not 2018. Okay. So the first cost itself is 1E16. So you're telling me that in 28 parts, right? You always be the wrong one. Well, in starting you have nm, and then you have 2 or nm by, but that's only if it divides it. Oh, If x doesn't divide n, then the whole column is free. So if I reach a path such that it is 0, I can just go up and reach to some big y such that it's 0 and try to form a. So basically after that I can just traverse around the whole grid and find any entry point such that it is possible. So technically the grid would be something like this. Let's say this is 0. So you have this cell being highlighted, then you have this cell being highlighted. There are very few devices, right? So this what written for most of it's like this. So this. Every 0 cell is connected to each other. We need to find min cost to reach a 0 cell. So if I had to remove the problem to from 1 1 reach a cell such that both are things. So from 1 1 I can go to 1 2 or 2 1, and if both are even then I can go to 3 3 or so then it's never it's just the point going to 2. I can check 3. So it's a 3 or n by 3. It's always better to go to that cell since it's better than going to n by 2. You will either be n by 3, n by 3, which is still fine. Unless it is divisible by 2, but we are just considering very large n and m here. So you have that, and then you want to find, let me just find a way to get this. So you have me, then I'll jump here or here. So 1 2 3 4 2 1 2 3 4. So if say it's even, that says divisible by 3 2. So 2 2's there's no point. 1 3 or and they chose smaller. So again, one thing to remember is if they are both divisible at some point, then this whole region would become pink. But that's too small. So you have this. At some point it's going to give up. At some point this is going to give up. So it's just a matter of what's the closest part to hit one of these reds. So now you have so when is I greater than n by I if I is greater than root n. So that's a case we shouldn't worry about because that's very small for NNM. We can brute force that separately, but what I'm worried about is this. Is so you have, let's say, I go here. Is this better or this cakewalk pattern? But I think this can be brute forced since what? It should be very small, right? You can't have n factorial. I mean, 10 factorial would have more than that digits. How many digits does 10 factorial have? 3, 9. So I would need a 9 cross 9 grid and brute force it to find the first time it takes red. Then I do the same thing for n and find the bounce there and find the closest path for it to reach 0, 0. And then if it's here, I can just print the distance. If not, I can do that. That seems perfect. And I can just BFS this. Or can I BFS this? Or will I have to Bellman for this shit? So basically, they're like what? 81 cells here, and in 81 cells, I want to find the closest path. So these unnecessary paths will never be optimal. So it's either right or up left. So I would just have to do a DP. I will make a helper function. So I will have one function that returns the DP. So I'll have a ans variable. Gans. Let me just implement it twice. Find the minimum distance. Now for yeah, I'll just traverse like this. PP of 1 is 0. Actually, it's the source to 0 and get min of this with dpij. So if p less than equal to x and q less than equals to y, output dp pq return. So if this is not the case, then it has to be somewhere else. So I will have to calculate another dp array. So pick xt equals p. So in this case I'll have to get the drift. It's not that easy because I can move left or right. But if it's too big, there are not much spaces either. So I have to check 4 corners. This. This question is too much implementation work unless I'm missing something. So block here. So if this is not 0, 0, there might be something which says that it's 0, 0. And which I would think, but if this divides it, this won't. I mean, it might. There's nothing to say. It's just that there can't be much. So you have this. Now, handle case. Cost of PQ is 0. So now I will have to make 1 dp here, 1 dp here, 1 dp here, 1 dp here, unless I can do something smart about it, which is there any clear strategy of moving to reach a particular y or x? So let's say I have 100, right? So you have 1, you have 100. So 1e4, what is it? 10, 10, 5, 5, or 12, 12. So you have 1, 4, 4, and you have this by 2. So 72 for 36. So this keeps decreasing. 7, you have a 0, and now you go here, it's going to be lesser, so these would be less, so it would be better to go here, then here, then here, and so on. Until I hit 1. So that just means I keep greedily going to the what's next smaller. It's not always true. So it's true here, but I already done DP for that. My issue is, will this be better than this, assuming there's a lot here? So I don't think a greedy is the best thing. I'll just do a DP. But I'll have to, it's better if I just parameterize it. Or I just make one big thing and fill it. I can just do that. would pass easily. So right to be y up q, y down q. So if uh, uh, n mod p not equal 0 or m mod q is not equal 0, in that case you can just output source to 0, return. Now it's not 0, then in that case for x right while it's dividing n x right plus plus for x m mod y right to the 0, y right plus plus. Actually, I may just use a map for it. I think it should pass. Q j less equals to y up j plus plus. This goes down, this goes right. Now the other quadrant. YOLO. Oh, where have I used int? Yeah, I'll have to stress test. Whew. Set major. National Ball. Reminds me of bull sorting algorithm. So now I have to tell you the number of prefixes are dominating. Well, in this case, I'll just have to find the largest prefixes dominating. But what's the other property? Oh, what are the constraints? 285. Now if but I can't just say that if this is if this prefix is dominating, this prefix is also dominating. Well, if an array is dominating, then all prefixes are dominating by the definition. Now I just need to find. So the suffixes are dominating as well. Should the dominating array have the same element? Well, so size 1, you have. When can it switch? Is what I'm guessing. Oh no, it can't switch. So consider this. So this is dominating with element m. So you have m, which appears k times, such that k is larger than, so let's say this is of length l, so it's strictly some number strictly greater than l by 2. Now, but what point can m, the majority element, change from m to m1 dash? So let's say you have m dash here. Now it can change into this if so if it changes here and increases it, then this becomes, so let's say it's just close, so let's say m is equals to l by 2 plus 1 and m dash is equals to l by 2. Now if I increase this by 1, then they both become equal, so there's no majority, but all prefix suffixes must have a majority. Therefore in a dominating array, the dominating element remains the same over all prefixes and suffixes. So now and since it's going to start from the same suffix, it's going to be an m. So whatever this is, now we have to find for how long will m would be a dominating element. So it's sort of dominating element. So how do I check if m is a dominating for everyone? Yeah. And it would end at a dominating element as well. So basically, thing is, if you have m, then you must have an m again. Now you have a leeway to do an l. Now, although now you have to have an m again, then you have a leeway for another l. Now we must have an m again. So it's going to be ml. This is your most ideal case of evenness. Or you will have a series of m's, and then you will have an L matching it, but this can only happen if you have another series of L. The prefix and suffix constraint make it strong, but it also becomes difficult to formalize based on that. So one hypothesis I could make is never mind. So why is it easy to just check for prefixes? Not sure. So given to a C and B each containing AND eachers, you are allowed to perform the following operation many times as much as you like. Firstly 0, choose an index I, swap bi, find the maximum possible value of the expression an plus bn. So the question just becomes, do I want that bit to be there? If it's not possible, just move on to the next bit. I would have to do something. Alright. That is it easier. What kind of arrays are dominating? So let's write it. So we know it should start at under 10, and second element also has to be m. Now third element can be L or L, say m. So now I have two more leeways. M here, number of m here. So basically, according to Boole's voting algorithm, number of, let's say, Moore's voting algorithm consider equal as 1 and unequal as -1 if the count should be greater than or equal to 0. But in this case, it's not just greater than or equal to 0, it should be strictly greater than 0 at all points. So you start with 1, 2, and you end at whatever. That is so interesting. So if I consider subarrays, so now you want contiguous subarrays, right? Say the dominating element is m, find number of such arrays. It's not necessarily that all the prefixes are also dominating. Perfect. This brings me to my next point. No, prefixes don't need to be dominating. Prefixes just need to have a majority element. So if you have a dominating array, so if your DA with end count greater than also greater than 0, So do I have an n square solution or more like an n cube solution? So for each element, I would first iterate over lengths. Now if I know this is dominating of length d, and I know this, so from I to n, I know what's the max length that is dominating. But doesn't mean or. So if I have a phi 1 phi, sorry, phi 1 1, what was I thinking? Uh, so if you have a dominating array, now oh, so for each distinct value, I will filter out the indices where it exists. Then For each, I will calculate the last time it becomes first. Let me do this, then I can think about the rest. I have 13 minutes to implement this. Now for each I would have to find the last element that it is 1 in. How would I do that? Now you know it's 1, 1, 1, 1, and you know it's just 3, 6, 8, 9. So this one, so those be equal this. How do I do this? Bunny so just too slow. Well, I can do it the monotonic stack. So have a prefix array. So for max right, or the value and the index, which is 1. If this minus this is less than 0, if j plus 1, j plus 2, so if j plus 1, if jp1 minus fj is less than or equal to 0, this has to be less than 0, then answer for j plus 1 that'll never happen. Very amazing. Perfect. So you have right dot push pref of I plus 1 and while not pref of I dot while it's not empty and pref while it's not empty and right dot top's first element is less than or equal to pref of I, then actually it's not just less than equal to, it could be equal to. So the condition's a bit more complex. So one is this. So this is a short and so the other condition is basically when you have I I minus 1, I minus 2, and so this is positive, so it's all good, but it had gone negative here. And the way that could happen is this is 1 and this is 0. So pref pi is here, and that's the exact same number of so I, and since it's going to be telling that it actually is right now, I have to convert back to the real world to check. Big comma 2. I'm not gonna finish it, but so you check that if so the real curve is vec of index and int real before is vec of it's it's a bit more disgusting, the implementation. So basically the idea was I would make indices for each distinct index. So let's say you have this test case, right? So here I would make an array of 1 such that it's 0, 1, 2, and then for each index I would see how far could I go and still have 1 be the majority, and how far I can go from here and still 1 be majority, so on, and then make similar thing for right. And then for each index in the range where it remains a majority, find number of indices such that I remain in majority. So that was a solution, but the implementation details seem to be a bit dirty, so will not be able to finish in time. But that's the idea. And for the previous problems, you have max swap. What the no? So you had P3. Yeah, so this was again a brute force bash. So one thing you would have to realize is that you can't have multiple contiguous cells which are divisible by which can divide n and m. So, and if you reach a 0, then it's always 0. So there are 3 cases. One is you directly reach it through a set of cells that x and y both divide n and m respectively, or you go to a 0 cell and through a 0 cell reach the target. So for that, my implementation is not the neatest, but it works. So for first I do a simple DP to find the number of to find the min path from 1 1 to the 0 cells, then do a more complex one for, I mean by more complex just more lines, since there are 4 quadrants to take care of, from target to a cell where you cost is 0, and then I take that and return. And what was B? It's funny, both have 156 sols. So in this case, yeah, it was just observation that uh, you can reach it only if the sign remains the same. And is this the second one? Yeah, and what is this? Yeah, again, this was just greedy. So let's see if I'm 6 starring. Oh, looks like I'll be 6 starring. That's great. Good thing I recorded it. Yeah, that's it. Thanks for watching.